Welcome to this explainer. Today, we're going to trace the ultimate origin story of the physical universe. And honestly, we're not just talking about some distant, dusty galaxies today. We are uncovering the deeply personal, literal connection that you and I have to the cosmos. Let's dive right in. Seriously, I want you to literally look at your hands right now. Think about the heavy elements that make up our daily lives. You know, the gold on your ring finger, the iron coursing through the hemoglobin in your blood, the calcium in your very bones. Where do they actually come from? Because, as we're going to see, they didn't just magically appear out of nowhere when the Earth formed. Which brings us to part one, the mystery of our origins. So, back in the early universe, things were pretty basic. It was essentially just a giant soup of hydrogen and helium. The crucial point here is this. Basically, nothing heavier than lithium existed initially. Literally no carbon for life, no oxygen to breathe, no silicon for rocks. That means a massive, universe-spanning manufacturing process had to happen to create the building blocks of our planet, and, well, by extension, our bodies. And that leads us to part two, stars as cosmic factories. The core of a star is essentially the ultimate pressure cooker. You have this absolutely immense gravity pulling everything inward, constantly trying to crush the star. Now, this gravity creates such extreme pressure and heat at the center that it literally forces atomic nuclei to merge together. This is nuclear fusion. It's the process that releases the energy making a star shine, but more importantly for us, it's the exact mechanism that forges entirely new elements. Let's look at how this builds step by step. A massive star spends most of its life just turning hydrogen into helium. But when the hydrogen runs out, the core contracts, heats up even more, and starts burning helium into carbon, then carbon into silicon, and finally, silicon into iron. You can kind of imagine the star like a giant cosmic onion, building up layers of increasingly heavier elements inside its core as it ages. Moving right along to part three, the iron dead end. Now, what's really fascinating here is the totally unique nature of iron. Iron is actually the most tightly bound nucleus in the entire periodic table. Extracting energy by fusing iron is literally physically impossible. In fact, it costs energy. So the moment the core becomes pure iron, the nuclear furnace just shuts off. That outward pressure that's been fighting gravity for millions of years, it simply vanishes. And this is where things happen in an absolute split second. Without that outward pressure, gravity takes over completely. The entire core collapses inward at unimaginable speeds. It gets so unbelievably dense that electrons and protons are literally crushed together to form neutrons. The density skyrockets until the core cannot be compressed a single millimeter further. And then, it violently bounces back. It acts exactly like a tightly coiled spring that has suddenly been released. Which takes us to part four, supernovae, the ultimate forges. We need to carefully contrast two distinct types of these explosions, mostly because they give us completely different chemical gifts. On the left, we have the core collapse supernova we just described. That violent bounce creates a flood of neutrons, rapidly forging the rarest, most precious elements in the universe, like gold, silver, lead, and uranium. But on the right, we have a type 1a, or thermonuclear supernova. This happens when a dead star called a white dwarf steals way too much matter from a neighbor and just completely detonates. This specific explosion is nature's primary factory for creating massive amounts of iron. To truly understand a supernova, you really need to grasp the sheer scale of the energy involved. Just look at this mind-blowing number, 2 × 10 to the 43rd power joules. That represents the kinetic energy released in a single core collapse supernova. Let's put that massive number into a pretty terrifying perspective, actually. That is the energy equivalent of taking the mass of 5 entire suns and throwing them outward at thousands of kilometers per second. And here is the truly crazy part. That kinetic energy, we can actually see, it represents only about 1% of the explosion's total energy. The other 99% is carried away by ghostly subatomic particles radiating out into the void. Absolutely wild. Here we are at part 5, seeding the interstellar medium. So this apocalyptic destruction is actually an act of beautiful cosmic creation. The explosion sends shockwaves blasting outward at thousands of kilometers per second. All those newly forged elements, the carbon, the oxygen, the gold, the iron, they are thrown out of the dead star's core and into the empty void. As these shockwaves sweep through space, they compress and heat the thin interstellar gas. Over millions of years, the supernova acts as a kind of cosmic fertilizer, chemically enriching the entire galaxy with heavy elements. And this brilliant data illustrates exactly how we know this is all true. We are looking at a visual fingerprint of our galaxy's history. It shows the ratio of alpha elements, things like magnesium and calcium, compared to iron. Now, in the first billion years, the primary explosions were fast-burning massive stars, which are really rich in alpha elements. But as time went on, slower developing white dwarfs started exploding, suddenly flooding the galaxy with iron. That causes that super dramatic shift you see on the right side of the chart. The data perfectly tracks our origin story.
Finally, part 6, we are made of stardust.
Those ancient drifting gas clouds, the ones heated and fertilized by the explosive deaths of massive stars, well, they didn't just float around forever. Over eons, gravity pulled those chemically enriched clouds back together. They collapsed, spinning and flattening to form a new disk. In the center, a new star ignited, which is our sun, and the remaining dust and heavy elements smashed together to form planets, to form Earth. Which leads us to this totally inescapable, profound conclusion. We are the living, breathing remnants of dead stars. Every ounce of iron in your blood that carries oxygen, every speck of calcium in your teeth, every single bit of carbon that forms the structure of your cells, it was all forged in the belly of a massive star and blasted across the galaxy in a supernova explosion billions of years ago. So, I'll leave you with this. The next time you walk outside and look up at the night sky, don't just see distant, disconnected lights. Realize that you are inextricably linked to them. Do you now realize that you are not just in the universe, but that you are the universe, finally waking up and looking back at itself? Thank you so much for joining me on this explainer, and as always, keep looking up.